Welcome. In today's video, I'm going to show you how to basically calculate the magnitude, direction of a vector, and the angle between two vectors. So basically, if you have a vector, let's start with the magnitude. How do we get the magnitude of a vector? So if you have a vector v, all right, equals 3i plus 7j, okay, and this vector can be written basically or drawn if we want to visualize it. All right, let's call this 3 and 7 right here. So this goes in this direction, 3 units to the right and 7 units upward. So the vector is 3 units to the right and 7 units upward. So the vector is this essentially. All right, and this is your vector v, or at least the magnitude of your vector v goes in this direction. So to be able to get the magnitude of this vector, you basically have to take the square root of the square of the I component plus the square of the j component. All right, and basically that will give you 9 plus 49 square root equals to the square root of 58. And you can simplify this more or change it to decimal places if you like, but this is basically the magnitude of this vector v right here. Now to get the direction of the vector, we're going to use SOHCAHTOA, and in this case you will know that the angle of this vector will be here, the displacement of the vector in space basically, so you want this angle theta. All right, and considering what quadrant it is in, this is the first quadrant right here, quadrant 1. This is the second quadrant, this is the third quadrant, and this is the fourth quadrant. And since this is the first quadrant, your angle would just be your referencing. Let's call this referencing R. But if it was in the second quadrant, your angle would be 180 degrees minus your referencing. If it's in the third quadrant, it's going to be 180 degrees plus your referencing. And if it's in the fourth quadrant, it's going to be 360 degrees minus your referencing. All right, so to get this angle here, we're going to have to use TOA, meaning opposite of adjacent. You know your opposite is 7 units, your adjacent is 3 units. So we're going to use TOA, all right, meaning your angle will be equal to the tan inverse of 7 over 3, opposite over adjacent, which if you punch it in your calculator, make sure your calculator is in degrees. If you punch in your calculator, you're going to get 66.801 degrees, and that's your angle, right? And this is in 2 dimensions. It also works the same way, mostly the exact same steps if this was in 3 dimensions as well. All right, moving on from that, to get the angle between 2 vectors, taking 2 vectors, all right, let's call your first vector u, and this would be equals to 3i plus 7j, and then call your second vector v, and this would be equals to 9i minus 4j. All right, the formula to get the angle between 2 vectors is cosine theta equals u plus v, or u dot v, right, divided by the magnitude of u times the magnitude of v. Okay, and to get the angle from this, you're just going to say angle equals cosine inverse of u dot v divided by the magnitude of u times the magnitude of v. All right, keeping this in mind, now what we need to do is basically do the dot multiplication of u times v, and this will be an element by element multiplication. So you're going to say 3 times 9, all right, plus 7 times -4. Okay. And if you're not very familiar with what dot multiplication of vectors implies, that you can watch one of my other YouTube videos that talks about that. All right. And basically this will give you -1. Okay, and then you need the magnitude of u, of your vector u. So you're gonna say the square root of 3 squared plus 7 squared, and this is going to give you the square root of 58. And you need the magnitude of v as well. You're gonna say 9 squared plus -4 squared, and this is gonna give you the square root of 97. Okay, so in essence, remembering that the cosine of theta equals dot product of u times v divided by the magnitude of u times the magnitude of v. This will be now then equals to -1 divided by the square root of 58 times the square root of 97. All right, which implies basically that theta will be equals to cosine inverse of -1 all over 58 times 97. And if you punch this to your calculator, once again, make sure your calculator is in degrees, and make sure this is in parentheses if you're doing this all at once. And that's going to give you 90.7639 degrees. And that's your answer. Thank you.